Okay, good afternoon, guys. Today we're talking about one of the very important concepts in physics: work, energy, and power. So let's see one by one. Work. What is meant by work? So generally, in the students' minds, we found two terminologies when you are reading a lesson of work, energy, and power. So certainly those two are work and work done. So certainly we have two terminologies, that is work and work done. So today I will tell you the difference between these two. Actually only work is there in physics. So that is the English terminology. That is work done is an English terminology. So when you are using some force against the work, so that is called work done. Let's say an example you understood, you people. Suppose let's take an example. I take a block here. I take a block of mass m and apply the force with that force F is I'm applying, so with the angle theta. So because of that it displaces. So it displaces of a displacement of S. So now generally when the work done is always in the direction of the displacement. The force is always the direction of displacement. So now the force is there in the with an angle theta. So what we have to do is that now we have to find out how much force experience on this horizontal line. I want to calculate the force experience on this horizontal line. For that I have to take vector components or compound resolutions we have to take. So this is, guys, what will happen. This is f cos theta and vertically it become a f sin theta. So just now what I told, so always the force act upon S. So now what is work? So work is equal to F cos theta into S. F cos theta into S. So we know that now I am doing F S cos theta. So we observe this, obviously Fs cos theta nothing but F bar dot S bar. So F bar dot S bar, which means here, so what is work done? So work done by this force. So that is the W here. So how to render this W? W is equal to work done by the force. The force F. So now we are in the terminology work done. So that is the meaning of it actually. So work done by the force F. That work done is how much, guys? W is equal to F bar dot S bar. Which means here we observe we people. So let us take an example. So the block is here. I am applying the force in this direction, but its displacement in this direction. Let us assume the displacement is happening in this direction. So the displacement is happening in this direction. So S bar is happening in this direction. F bar is against to the F bar. F bar against to the S bar. So what is the angle between F bar and S bar? F bar and S bar are anti-parallel. So this is our anti-parallel. So when F bar and S bar are anti-parallel, so theta become 180 degrees. Theta become 180 degrees. So when theta become 180 degrees, what will happen? The resultant of that. So now work done by the force F, let us say force F work done by the force F, W F is equal to F bar dot S bar. So F bar dot S bar into cos theta. So F bar dot S bar, cos theta means what? Theta means what here? 180 degrees. So what do you get? Fs minus 1. So cos 180 means what, guys? Minus 1. So what will happen? Resultant of that? Minus Fs. So minus Fs will happen here. So the work done by the force become negative now. The work done by the force is a negative amount. Is a negative. So negative will be get here. Same thing I am doing with that. So now he is in same direction. So both are in same direction. Now what I have to get? So let us say an example. F bar and S bar are same direction. This F bar and S bar are same direction. Then what will happen, guys? So theta is equal to same direction means 0 degrees. Same I am applying. Work done against this force. Work done against this force. So F bar dot S bar. So F bar S bar cos theta. So F bar S bar cos 0. So I have to get Fs. So this is the value is positive. So positive work done by the force I am getting here. So positive work done. Let us an example. Now the angle is become theta is equal to pi by 2. So which means so force is acting like this and displacement is happened like this. So what is the angle between these two? So angle between these two is pi by 2. Now what is the work done by that force? Let's see guys, what is the work done by that force? So work done by that force is that the work done by the force Wf is equal to once again F bar dot S bar. So F bar S bar cos G cos 90. So cos 90 become what guys? 0. So how much force, how much work done by that force is become 0 joules. So this is the three types of work done generally found in our day-to-day life. Next comes to the what are the units? So generally units is that SI unit is joule and CJS unit is that erg. So generally we have erg. So erg is one is joule and another one is that erg. Let's say guys, what is the relation between joule and erg? So 1 joule is equal to, I want to calculate how many ergs. So that I want to calculate. Very simple guys. So we know what is meant by work done. Work done is equal to F into S. F means that MAS 1 in terms of gram I want. So gram. 1 kg is equal to how many grams guys? 10 power 3. A means meter per second square. Meter means that 10 square centimeter, meter per second square, centimeter by second square, and S means the displacement once again 10 power 10 power square centimeters. So now what will happen is 10 power 3 plus 10 power 7 gram centimeter square by S square. This gram centimeter by S square is called what guys? Erg. So erg is equal to 10 power 7 x. So 1 joule is equal to 10 power 7 x. 1 erg is equal to 10 power minus 7 joules. So 10 power minus 7 joules. So what is the dimension formula? So dimension formula generally we see the dimension formula for this m power 1 according to this m power 1 L power 1. So that is we have come here gram m power 1 centimeter square means that L square t power minus 2 which is there in the denominator. So what you get guys? M power 1 L square t power minus 2. So I am requesting all the people please subscribe my channel for see more content. Thank you people.